Welcome, this is Dr. Plague. Now, first of all, I'd like to apologize for the long hiatus I took since my last video. In my last update video, I mentioned that I was not quitting YouTube. Then I ended up taking about a 4-month pause. So, for that, I apologize. I have been quite busy and I've been in the process of updating my lab. I'll talk more about that a little later. But first, let's take a look at some counterfeit ZIF sockets that I came across. You see, I was in the process of working on my next video in which I create a flash memory programmer, and I was going to use one of these here ZIF sockets that I purchased a while back. Now, these were only $2 a piece, so I purchased 10 of them. Then, when I was trying to use them, I noticed that one had a bent contact, so you couldn't insert an IC correctly into it. So I took it apart to repair it. Now, I knew that at $2 a piece, these were probably not authentic, but I thought that maybe there was an off chance that the place I purchased them from just had a surplus and needed to get rid of them. But then I noticed that these were in fact counterfeit. I'll explain a little later how I discovered that. Now I want to show why $2 appeared to be a real bargain for these. So let's look up some ZIF sockets on DigiKey to see how much they really cost. And just so you know, this is a 40-pin ZIF socket. However, the flash memory chip that I'll be using is only 32 pins. So, in reality, I only need a 32-pin ZIF socket, but I only found the 40-pin version for $2. Now, let's go to DigiKey and search for ZIF IC sockets. And let's first look up 32-pin versions to see what's available. And we get 78 results, but it looks like most of them aren't in stock. So, let's see how many are in stock. And there's only 4. So it's just these top ones here. And the prices are pretty high. $23.36, $16.20, a whopping $42.75, and finally $28.02. Wow, that really makes the $2 version look attractive, doesn't it? So now let's look up what we have for 40-pin versions. And let's see if we can find the one most similar to what I purchased. And I only want to search for authentic 3M ZIFs, since they own the Textool trademark. And the ones I purchased are supposedly Textool. And we only get 4 options, of which one of them is obsolete. And wow, look at the prices of these. $31.61, $46.28, and $46.16. This one has some alignment pins, and this one has wide slots. Yeah, this one looks similar to what I have. So the ones I purchased cost less than 10% of the authentic ones. Now let's check out other manufacturers besides 3M and see what kind of pricing we have. And I'll sort them by price. So the cheapest one they have is only $3, but there's no image of that one. Check this one out for $4. It's sold by Adafruit, but the image shows 3M on it. Do you think this could actually be an authentic 3M part for only $4? You know what? I actually purchased one of the $4 Adafruit ZIF sockets right here, so we can see what we really get for just $4. And I have to say, what I received kind of shocked me. This is not at all what I was expecting. And I'll show you what I got a little later. Now, let's shift over to the $2 ZIF sockets. I looked up how to determine if a ZIF socket is counterfeit, and one good way to tell is to look at the Textool logo on it. Counterfeit sockets will generally misspell the Textool name. For example, they'll replace an E with an F, or replace an O with a D. So, let's take a look at this. The second O is actually a D. I did not get a Textool. I got a Textoddle. You know, I didn't even notice this when I first got these parts. And I did look at the name, but I totally missed the misspelling. Unbelievable! These do seem to work just fine, and they seem to look like a decent ZIF socket. I guess time will tell if they start failing in any way. Look at this. They have a U.S. patent number on them. Let's look that up and see what the patent is. So the application was filed by TextTool, but it looks like it's expired. Let's take a look at the document. And, this looks a lot like what we have, but this is an authentic TextTool patent. Is it even legal to use someone else's expired patent? That's a good question. Let's see if we can find an answer. Can you legally use an expired patent number? Yeah, look at this. United States federal law bars companies from marking products with erroneous or expired patent numbers. And there's also an AI answer. Marking a product with an expired patent number can be considered fraud and false marketing, and could result in liability. So, yeah, it looks like that is illegal because, everything you read on the internet must be true, right? I can believe that this one is probably true. But what I don't understand is why you would put an expired patent number on a product and try to mislead the purchaser. The patent is expired. Couldn't they have just produced the ZIF socket under their own name and left the patent number off? Wouldn't that have been a legal way to sell it? I wouldn't have a problem purchasing another brand of ZIF socket at a low price like what these are being sold for. I just don't like how they are misleading us into thinking these are a name brand. You know what? I noticed that these have a different patent number under the TextToddle name. Let's look this one up. And this one is another expired patent filed by Arthur Vincent. And what the heck is this? It's for an interest calculator. Are you kidding me? This isn't even a related patent number. They're just pulling patent numbers out of nowhere. I need to see this document. What am I looking at? Oh, wow. This is just unbelievable. What were they thinking of when they put this patent number on the socket? Well, let's compare the counterfeit socket to a real TextTool socket. Here is an older TextTool socket, not a 40-pin, but rather a 24-pin, since I don't have any authentic 40-pin versions. And notice that TextTool is spelled correctly. Here's a side-by-side comparison. Let's take a closer look at the counterfeit version. And the plastic doesn't have very clean edges by the contacts here. Very sloppy. Also, look at the screw. It's not flush, making the assembly look pretty poor. Compare that to the authentic socket. Look at how good this one looks. Countersunk. Nice. And the plastic by the contacts look much cleaner. Now, I don't really want to give away the name of the company that sold these ZIF sockets, since I don't think they were purposely selling counterfeit parts. I'm sure they just received a surplus of parts and just needed to get rid of them. But I did actually buy some other items from them, such as these 555 timer ICs. I don't know for sure, but I believe these may also be counterfeit. But at least they do seem to work. They work, but don't seem to work at as high of frequencies as other 555 timers that I have. And, strangely, they have a lower resistance between pins 5 and 8, and pins 1 and 8. The first IC is the suspicious one, and pins 5 and 8 have a resistance under 4K, and it should be close to 5K. Also, pins 1 and 8 are under 12K, and should be close to 15K. Let's check these other 555 timers. This one has 4.68K and 14.74K, while this one has 4.7K and 14.77K. Let's look at some other 555 replacements. I have a bunch of MC 1455s here, and this one has about 4.81K and 15.4K. So, what makes me think that these are counterfeit? Well, let's take a look at the logo on it. It looks kind of like they are trying to imitate the TI logo, doesn't it? From a distance, it looked like the TI logo to me, but up close it does look different. Is this really an authentic manufacturer's logo? I don't recognize it, but if anyone else recognizes it, and it's not counterfeit, then please leave a comment to let the rest of us know. It is not the same as the TI logo, but similar. Here is an authentic TI logo from a part bought from DigiKey. Notice that there is an eye inside of a shape of the state of Texas. Now let's compare them side by side. What do you think? Is it counterfeit or some other authentic manufacturer? Here's one more counterfeit item that I got from the same company. It's a K2 meter. The missus wanted to try some ghost hunting since we have had some strange things happen in our new house. This one actually had quite a few telltale signs that it is fake, including the overly bright LEDs on it. But it does seem to work. Now, with all that said, I'd like to talk a little about what's been happening with my lab. As I said, I have been quite busy lately, and it seems like as I get older, I keep finding less and less time to work on things. Hence the long pause between videos. Also, since I work from home, I need to share my lab between real work and creating videos. So I've been working slowly on updating my lab. As I mentioned in my last update video, I've installed a new workbench over there to give me more space to work. I also mentioned that I planned on getting some new equipment for that workbench. So now I'll show you some of the new equipment that I purchased. I will talk a little about each one, but I don't plan on making any in-depth reviews on these. So here's the first item I got. It's a new linear power supply, and it will go on the bench here for now. We need to be able to power up projects that we're working on, so therefore I chose to get a new power supply. This is a Unity UDP 3305S 4-channel programmable DC power supply. The first two channels are adjustable up to 33 volts and 5.2 amps. The third channel can reach 6.2 volts and 3.2 amps, with common presets of 1.8, 2.5, 3.3, and 5 volts. The fourth channel, if you can even call it a channel, is just a non-adjustable 5-volt 2-amp USB output. Now, I couldn't find any dimensions for this power supply on the internet, so I've added those into the video description in case anyone is interested. So far, I have no complaints. It seems fine for what it is. I would have liked to get another of these 4-channel supplies back here, which can be adjusted in 0.1 milliamp increments, while the Unity only has 1 milliamp increments. And yes, I do need that small of increments for my work. Also, this one has 2 electronic loads built in, but it was much more expensive than the Unity. So, since I already have one of these, I chose the less expensive Unity for my new supply. Next, I need another scope for the new bench. It will go here for now. I chose the new 12-bit Regal HDO 924S 250 MHz scope. The primary reason I chose this scope is due to the HDMI output. You see, along with the new equipment, I also purchased some video capture equipment so I can make some better quality videos in the future. I can now capture composite video for future videos when I work on designing video circuits. Also, I can capture VGA, specifically for this Tektronix scope since it does have a VGA output. And finally, I can capture HDMI, so I can now capture directly from the HDMI port on this new scope. I don't have the logic probes for the Tektronix scope, so I will probably be using the Regal for that in future videos. Now, there are probably a lot of review videos for this scope, so I won't be adding much, But I do want to mention a couple improvements from this DS1000 series scope that I noticed. First of all, the DS1000 consumed one analog channel for each 8 digital channels that were active, meaning that if you used all 16 digital channels, then you could only use 2 of the analog channels. The new DHO-924S appears to allow all 16 digital channels and all 4 analog channels to be used simultaneously. Fantastic! Also, the DS1000 couldn't output a 0 to 5 volt square wave on its waveform generator output. It could only output up to 2.5 volts. The DHO-924S can output a square wave that is 0 to 5 volts up to 10 megahertz. Perfect! The next thing I got was the 16-channel PLA2216 logic probe. I know there are some DIY versions, but I prefer authentic equipment. Now here we start to see some shrinkflation. You see, it used to come with 32 leads and 32 grabbers, but now they have reduced that to 20 of each. However, I was actually shorted 1 grabber. They only gave me 19 of them. I have sent them an email about this, so we'll see if and how they respond. I'll keep you updated in the video description if I ever receive a response from them. In the meantime, I have 32 of them from the DS1000 scope. Here are the 19 grabbers, the probe head, the leads, and stickers for the leads. Now, one thing I noticed with this logic probe is that the probe head heated up much more than I would have imagined. In fact, as it was heating up, I noticed a snapping sound come from it as though a part had fried out. But it was probably just the expansion of the plastic casing. It was very hot to the touch, almost so hot that it felt like it could burn me. I used both a thermal imaging camera and a laser thermometer to measure the case temperature and found it to get up to 129 degrees Fahrenheit. You definitely want to have a fire extinguisher close by if using one of these. I can only imagine the internal PCB temperature. I did email my findings to Regal to see if this is normal and to be expected, or whether they think I got a defective unit. So, until I hear back from them, I don't want to use it for now. I did compare it to the logic probe on the DS1000, and that one felt warm to the touch, but not really hot like the new probe head. This side of the older probe head has a max temp of about 109 degrees. And this side is about 114 degrees. And both of those are in Fahrenheit. In conclusion, the new probe head gets about 15 degrees hotter than the old one. So again, I will add any updates I get on this in the video description. Now, I can power up circuits on this new workbench, provide a digital clock source, and analyze the circuits. What more could I ask for? Well, I know there's a lot more I could get, but this is a good start. Now, let's get back to the question that many of us are waiting for. What did I get from Adafruit through DigiKey? So, let's open this thing up. There it is. And what is this? They actually scratched off the name. Ah, just why would they do that? I mean, what are they trying to hide? You can see in the image on DigiKey that they clearly show this is 3M branded. Why remove the branding unless it's fake? Wouldn't they be proud to show an authentic 3M socket? The screw is nicely countersunk, and the plastic looks clean like an authentic 3M socket. But did 3M ever make black ZIF sockets? The authentic ones I have seen are all green. Everything else with this socket looks very nice, and it has the same patent number as the counterfeit socket. So, I don't know. Is this one a counterfeit, or is it a real 3M socket? Leave a comment and let us know your opinion. If you have any experience with any of the counterfeit ZIF sockets, such as quality, how long they last, do they wear out easily, etc., then please leave a comment. Well, that's all I have for today. I will try to get more videos made soon, but please understand if there are gaps between videos. I don't always have a lot of time to work on them. With that said, thanks for watching, and I'll see you next time, right here on on Dr. Plague.